Hello, welcome back. We're going to finally use the concept of a discriminant to help us kind of understand what these quadratic graphs might look like without actually having to graph them. It just gives us a general idea of what to expect. So for instance, take the first one, x squared minus 5x plus 4 equals 0. Let's say we wanted to figure out what this function looks like. You could say f of x is equal to this function. What's it going to generally look like? We want to, for these problems, we want to basically find the discriminant, and from that information, and not from any graphing, we basically want to figure out how many roots this function has. In other words, how many crossings does it have? So in order to find that discriminant, you just say b squared minus 4 times a times c. And we've done this enough that you can see that b is negative 5. That's this term right there. So it's negative 5 squared minus 4 times a, which is 1, because that's what's in front of there, times c, which is 4. So we just literally calculate this answer. That's going to be negative 5 squared is 25, minus the 4 times 1 times 4 is 16. So what we have is 25 minus 16 is 9. So what we have figured out is that the discriminant is greater than 0. So basically the discriminant, we'll just call it d here, it's greater than 0. And what does that mean? Remember our cases. When it's greater than 0, it means, and you can go back and look at the last lesson, we have 2 real roots. And if you forget why positive answers like this give us 2 real roots, just think about it. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So if you get the square root of 9 there, you're going to have a plus or minus 9, which is going to give you 2 distinct answers, 2 distinct real roots. Okay, now I didn't ask you this in the problem statement, but you can also figure out that because this is a positive quantity in front of the x squared, this parabola is going to open up. And that's just a general rule of thumb. If you have a positive number here, it's going to go open up, and if you have a negative, it's going to open down. And that's something we talked about quite a while back. You can look at the leading coefficient in front of the x squared term. If it's positive, the parabola opens up like a smiley face. If it's negative there, it opens like a frowny face. So if you really wanted to sketch this, and this is not a great sketch, but just as a general idea of what it looks like, you know that there's 2 roots, and you know that it opens up. So basically it's going to look generally like this, meaning that it opens up like a smiley face and it crosses at 2 points, so it has to dip below like this. Now this parabola might be over here, or it might be over here, or it might be over here, or it might be over here. I haven't calculated the roots, so I don't know, unless I calculate them, I don't know if the roots are over here or not, but in general it's going to dip below and